Hey, I know how to dance with your generation now. It's just jump up and down every single dance. There's like 100 people at it. I mean, just this. And I'm like, fast dance, hip hop, slow dance. I'm like, okay, that's just a little weird, but that's what I saw. It was just a jumping up and down out there. It's like, okay, well, that's an easy dance moves for watching you guys out there. All right, let's pull up our programming and see what's going on this week. We almost everyone's taking this. There's a couple of folks that are still missing the exam from last week. I see I got a bunch of things to grade this morning, so people turned in programs, people turned in the exam, which is just like that one question at the end I have to grade. So it won't take long, but I saw a whole stack of them there that I need to get to. So we'll do that today and get those in the grade book. So, all right, foundations of programming. Go to our grade screen. Let's see, we are done with module 1. This week we have processing numerical information. All right, processing numerical information. Then we got getting numeric input, the math module, the software development lifecycle. And then we won't have a test this module. We'll have a program that you write, the project for the end of it. So we got a program or two to write in this unit also, but we're just doing one thing a week here, guys. So gives you plenty of time to practice with your programs and stuff. So you need to learn. This is a programming class. We're going to write programs a lot, but we're doing 2.01. 2.01. So let's go to the activity screen. I'm going to close module 1 where I don't have to look at that every time. We'll just open module 2. Here's an intro here. There's no information as far as programming. It tells you what's coming up this unit. And it kind of details out all the lessons. It tells you how much time it should take to do it. It should take 45 minutes. 45 minutes. Oh, 90 minutes for the math module. That must be a program. It's going to take longer. But, this doesn't take very long for a lot of this. And we probably won't do the discussion-based assessment. That'd be 15 minutes per person. So. All right, let's talk numbers. I love talking numbers. I'm a math guy. I get into, I get lots of interesting discussions on numbers. In the world of programming, there are a few types of numbers. Right now, we'll focus on 2 of them, those with decimals and those without. That's the 2 types of numbers that we're going to focus on in this class. Try to contain your excitement. Okay, all right. Means we're not going to get into irrational numbers. Using numbers in your code opens up a whole new arena of programming, which is called calculations, right? If we have numbers, then we can do calculations. So this includes any program that involves points, levels, timing, leaderboards, moves, speeds, averages, tons more. Video games would be using calculations. It's important to know how to use calculations in programming. So numbers just got a little more exciting. Am I right? Well, I don't know that numbers could get more exciting when you're already at that high level. All right, so after completing this lesson, here's the objectives. We're going to be able to identify integers and floating point numbers. Floating point numbers are those decimals. We're going to understand how Python can be used to perform mathematical equations and use the string function to concatenate literals and numerical values. In other words, to print a number, we have a new command that we're going to learn. All right, so let's go to page 2 here. Words or numbers? Why pick just one, right? The world has words, which programs refer to as non-numeric. So we even call words by math terms. Non-numeric data, it's a string of characters. It's a combination of letters, numbers, or symbols. Cannot be used in calculations. You can't multiply pig times a number, right? It also has numbers, which we call numeric data. So non-numeric and numeric, and programmers work with both. So remember we talked about Ada Lovelace, who was back in the 1850s, the daughter of Lord Byron, the first programmer, daughter of the famous poet. She became an essayist, writing essays, and a mathematician. Without a doubt, she was both a number person and a word person, and actually we all are. Programmers use numbers in the program code to create your favorite social networks, and those numbers thrive on numbers. Think about it. Every post has pictures and words, but numbers are what matter. How many likes did it get? How many comments does it have? How many people are following you in the social media? How many shares did it have? So in the social networking world, numbers almost say as much as the words do. So they both have important jobs, numbers and words. Say life would be different today if we'd never figured out numbers. It'd be hard to get a paycheck, right? Because we wouldn't be able to buy things. You'd have to count how many you're buying. We have to have numbers. It's like, it'd be like no internet different. If there's no internet, life was different. No buildings, no agriculture, no medicine, because you have to have all these numbers to construct things, to build things. You have to measure. You need numbers. You have to do calculations. Lack of Wi-Fi would be our least of our worries if we couldn't build anything. So numbers can get pretty complicated. That's why we use calculators and computer programs. So Python has a great ability to help us crunch those numbers so we can stay out of the dark ages. So, all right, let's look over here. Next page. All right, integer. I'm the whole package. I like it. That's a nice little math pun because it's whole numbers. Integers are 1, 2, 3, 4, or -8, or 0, or 1042. It's numbers that are whole numbers, integers. Floats, I always have a point because it's 1.238. It's -5.6. It's 10.891. So the first thing is to learn how Python categorizes numbers, and it categorizes them by integer and float. Right? So if you're using a high-level programming language to say something the computer understands, like Python, you have to have specific terms so Python won't get confused. So there's 2 different numerical data types, and Python looks at them differently. Integer, int, refers to integers. That's the command that Python looks for, the int. And they're all positive and negative whole numbers, including 0. So here's an example of integers. -12, 4, 0, 234, negative. These are all integers. Float, when Python sees this, it's expecting decimal points, right? 0.0 would be something Python would recognize as a float number, and it would equal 0. 4.64, -234.145, all these numbers here. So why does this matter? Well, excellent question. There's actually 3 reasons. One thing with memory, maybe you're working with a program that takes up a lot of storage space, uses up a lot of your memory there. So floating point numbers take more space because you have to store the decimal part. It's not just 1, it's 1.384. So you can save yourself some memory. If you know there's not going to be any decimals in the numbers you're dealing with, you can call it an integer and it will not allocate as much memory space. Precision may be an issue. You may need a specific number. We may need that decimal to be more accurate. So floating point numbers allow for more precision. We can say 3, or we can say 3.158, right? 3.158 is much more specific than rounding it to 3. So this says if you're using 7.5, that's more specific than just using the integer 7. And arithmetic, you may need to have the correct math, right? If you're figuring up a purchase and you want to figure the tax on that purchase, you need to know more than the shoes cost $65. Well, actually, the shoes cost $65.48. You need all that 48 cents to calculate the taxes correctly and that kind of stuff. And to figure out the total bill, you need to add the cents, not just the integer part. So the results of integer math and floating point math are not always the same. What? Well, 11 divided by 5. Well, if you have it set as an integer, Python says that's 2. 11 divided by 5 is 2. But if you change it to a float, it's actually 2.2 because does not go in there evenly, right? So accuracy, you may need that accuracy. So floating point numbers or decimal numbers are important. Page 4, Python the calculator. All right, so in Python, we often assign values to variables, just like we did with inputs. We're going to assign a variable, so that way we can use the number. We need to assign it to a variable so we can do math with it. It can be numeric or alphanumeric. Alphanumeric has got alphabet numbers in there as well, right? The good thing is we don't have to tell Python which one we're using. It can tell, is this a numeric value or not? So let's say you want to create a Python program to help you with your math homework. So you might start with something like this in algebra class, x equals 5. Now here's the thing, in Python, the equal sign works a little differently. Doesn't work exactly like we write it in a math class. In programming, we use the equal sign to assign a value to a variable. The variable x now equals 5. X equals 5. X equals x plus 1. So add 1 to whatever x did equal before, and then print x. Yep, Python can handle that. You know, like in our last program, we said first name or whatever you used. Your first name equals, and then we assigned whatever the user input to that variable. That's what equal sign is used for. It's not used in math in Python. We'll see that in a second here. So we assign 5 to the variable x, then we added 1 right here. So now x is equal to 6, and that's what it would print. We could also use asterisk in Python to multiply, the slash here to divide, and more. Python does follow order of operations, right? Parentheses, then exponents, then multiplication, division, and then addition and subtraction. So you have to think about that. All right, so let's look at an example here in Python. It says read the code, predict the output. All right, so we have the comments. Define our main function. And here's another comment. So you don't have to put comments just at the beginning. Anytime you put a hashtag anywhere in the program, Python ignores that. But you may want to do that sometimes in a longer program, just so you can keep track of each group of commands so you know what they do. So this assigns the integer values. So we're assigning the number 11 to the variable x. We're assigning 5 to the variable y. So we've assigned that. And now we're going to do the arithmetic. And this tells us print arithmetic results. Arithmetic results right here as a comment. So Python ignores this line. This says print x plus y, x minus y, x times y, and x divided by y. So we would expect to see 4 arithmetic calculations in our output. So let's run our program. 11 plus 5. 16. 11 minus 5, which is 6. 11 times 5, 55. And 11 divided by 5. Now, again, these are integers. So Python says, oh, we're dealing with integers. So it did not say the answer was 2.2, which is more accurate. This just gave us the integer result of x divided by y, of 11 divided by 5. All right, so it assigns integer values because it saw no decimals. So it'll all be an integer. Let me see. Now let's go through the way it's going to do it. I was going to change some things, but let's see what it wants us to do. Okay, now it said float arithmetic. And assigned the float values. See the comments, assign the float values. A equals 20.0. So it knows this is not an integer, it's a floating value because of what we assigned to the variable. Then we assigned 2.5. So we're going to do the same 4 steps. We're going to add them, subtract them, multiply, divide. That's the end of the program. So let's run the program. Okay, so there's 20 plus 2.5, 20 minus 2.5, 20 times 2.5, and 20 divided by 2.5. And these are all accurate. Now notice, even when it's an integer answer, like 50, since we're using float numbers, we're using decimal numbers, it will give the answer as a decimal and let us know it is exactly 50.0, 8.0. If we had a weird number, like let's do 2.6, then when we run it, see, it's when you divide, it's 7.69230769231. And it probably continues. It stopped it after, let's see what it did. 3, 5, 6, 7, 8, 9, 10, 11. It did 11 decimals. Generally, 11 decimals is more than enough for whatever specific calculation you're doing. Let's look at their next example. Read the code, try to predict the output. Okay. So we assign now count equals 10, cost equals $8.99, $8.99. That's cost, all right? So this is saying we bought 10 items and they cost $8.99 each. Hashtag calculate total cost. Total cost would be the count, how many we're buying, times the cost. And then this is where we print the results, print the total cost. This is literally what's going to be printed because it's in quotations. And underneath that, it's going to print whatever the variable. So you notice that's what we assigned right here, variable. We're going to print what the variable equals. Let's run the program. 89.9. Total cost, 89.9. That's what it calculated. It took 10 times $8.99. It's $89.90. All right. Next. Here we've got num1, num2, num3. So we got three numbers, variables that we're assigning, 85, 95, 91. And we're going to calculate the average. So here's more calculations we can do. So the average equals number 1 plus number 2 plus number 3 divided by 3. All right, that's how we figure out an average. If you have three numbers, you add them together, you divide that total by 3, and that will give you the average between them. So what should the average be? It looks like 85 and 95. If we just have those two numbers, the average should be about 90. It would be 90 between those two, right? Because that's halfway in the middle. But then we're going to add one more number. So it's going to be a little bit more than 90 because that should raise the average. That's what we expect. It's important to know what to expect so you know if you programmed it right. Let's run it and see what it says the average is. It said the average was 210.33. Is that the average of 85, 95, and 91? What's wrong? Can anyone tell me what's wrong? Why did this not calculate our average correctly? There's where it calculated right there. Something's got to be wrong with that. Anyone see it?
Add parentheses.
Add parentheses. We need to add parentheses. We have to, because remember, it does order of operations. Well, order of operations, we got addition, addition, and division. It did the division first. The first thing it did was divide the third number by 3, because that's the order of operations. So it divided 91 by 3 and then added it to the first two numbers. So it added everything up. If we put parentheses to say, okay, we want you to add these 3 first, because parentheses is the first thing in order of operations, and then divide it by 3. Now let's run the program. Oh, look, the average is 90.3. 3, 3, 3, 3, a lot more 3s. That would be correct, because we said this would be 90 average, and then we just added a 91 to the total, so that would bring the average up just 0.3. Very good. Serendity's on top of it. She saw that. Parentheses. Told us we need to add those. All right, slide 5. Now let's see what we're doing here. Changing a variable's value. X equals 5. So the first thing we did was we took a variable X and we assigned a value to it. And we said, okay, the value of X is this. And then, so it should print 5, right? And then we took the value of X, we added 1 to it. And it says the new value of X is, and it prints the new value of X. And that's the end of the program. So when we run it, it says the value of X is 5, the new value is 6. Now what's it ask us to do? Make changes to the code so that the value of X is increased by 10. Okay, well, all we have to do is change our mathematical equation. Instead of adding 1, we just add 10. Run. Value of X is 5. The new value of X is 15. So yeah, you just type whatever math you want to do in here. We're changing the value of the expression. All right. They left this kind of open. So, all right. So your turn, it says. Define main. Entree equals, oh, they didn't give a price. Drink equals, tip equals. We're supposed to calculate the meal cost of an entree and drink. Entree and drink. Meal cost. That's without the tip, because after that it says calculate the meal cost with the tip and then print this. So here, I'm going to put this on a bigger screen where maybe we can see more of it here. I'm going to take, this is the window from, oh, it's not going to be much bigger, is it? It still only shows this much. So, but this is just our idle programming window. So let's see, do they Let's see, assign a value, and then we assign the tip. And we have to write the tip as a decimal. So they don't tell us what to assign. We get to pick the numbers we want. So entree, that's our main, that's what we're ordering. That's our meal. So let's say we're at a restaurant and we're going to order an entree, and let's say it's $12.99. And drinks today cost about $3. Let's make it 3.00. And let's see. So if it's $16, how much are you going to tip? Let's tip $3. Calculate the meal cost of the entree and the drink. So what's that equation going to look like? Put that in the chat. How would we add the meal cost for just not including the tip? The tip would be next. What equation would we use? Meal cost equals. How do we do that? Oh, Zach's on it. Entree plus drink. Because if this changes, we don't want to put $12.99 plus 3 because maybe they changed and got a different entree and now it's $10.99. Okay, let's run the program and see what it does right now. Oh, error because we haven't filled in this one yet. We need to fill in this one. Good job, Mary. Okay, Gavin, error because we have a total cost equal and we didn't assign anything. So how do we do meal cost with the tip? And there's more than one way to do that. There's two ways we can do this. Meal cost equal. Entree plus drink plus tip, says Daniel. What's the other way to do it? Anyone know? We can do this way. Entree plus drink plus tip.
We do like meal cost plus the
tip. Good job, Serenity. Since we've already calculated the entree plus the drink up here, we can just add the tip to meal cost. So that's the other way to do it. Let's run this way first. Entree plus drink plus tip. Total cost of meal is 18. That's the only thing we print is the total cost of meal. We didn't ever print meal cost because we hadn't added the tip yet, so we didn't care. The only thing we wanted total cost is what we want to print. Total cost of meal, which we put in quotes because we want to print, and we put a space after it, which we didn't really need because we put this on another line. So take out the space. It's going to look exactly the same. We said print total cost of meal and whatever that added up to be. Now, the other one, as Randy said, let's just say meal cost plus tip. We're exactly the same. Like we said, there's two ways to do it. Since we've done this calculation, we can just add the tip one. But either way is correct. Either way is correct. Entree plus drink plus tip, or meal cost plus tip. All right, good job, guys. All right, print the result. There we go. All right, let's look at our last page. Now we need to know more about printing numbers directly. All right. Eventually you'll find yourself, you're printing a zillion different statements. You're going to be printing more and more. So it get confusing. So your code can get pretty long, pretty messy. Let's see what they have here. Oh yeah, look at all those print statements they've got. On level 17 of the Epic game, your score is 1337. You have 4 lives left with 84% energy left. And everything had its own line that it printed on. It'd be a lot easier if we made these longer sentences. On level 17 of the Epic game, your score is 1337, period. Right? Instead of everything being on a different line, it'd be so much better looking, so much easier to understand, and more of it would fit on the screen if we just make that sentences. The problem is Python will not let you concatenate string literals and numbers. Like what? Well, let's see what this. What if we said the total cost of the meal was the meal cost plus I'm going to tip $5. Right? And I put the tip right here in my calculation. So I'm adding meal cost, which is a variable, and I'm adding $5 to it. Let's run this. Oh, that worked. Wait a minute. What am I doing? Oh, if I said, okay, total cost of meal, I put it down here, plus $5. Where here I'm printing this. These are both floating values right here. So that worked. But if I put it here where I'm printing letters and a number, or even if I just put meal cost here, or print on the same line. Forget this line. Total cost, sorry. I'm putting the wrong thing. I want total cost there. Total cost of meals, total cost. I said, I just want it on the same line instead of two lines. Type error cannot concatenate a string because this is a literal string literal. And this is a float value. It says I can't put both of those on the same line. Well, there is a way. There's a function called str, and you're going to love what it does. So let's say you have a number that you want to print, which was our total cost, along with a string literal. This is incorrect. If we said score is this, your epic score is, it's going to get an error, which we just did with our meal cost. But if we say str score, if we go over here and we say, okay, I know this is a floating value number. I know this is a number, and you don't like to print letters with numbers. So I'm going to tell you this command, str, and put this in parentheses. I put this in parentheses with str, and that tells Python, I know this is a number, but treat it like a string literal. So then I'm just printing two string literals. Print it like it's a string, but print it like it's letters. Just act like it's letters and just print it. That's what you're telling Python. I know it's a number, but act like it's not. Now when we run it, total cost of meal, $20.99. It's on the same line. Because we use concatenation and put them on the same line. If we want to put a period at the end, we can do that plus period. In quotes, actually print a period. See, now it puts a period at the end. So we can use this command, str, to force Python to treat it like it's any other letters. Treat this like it's a literal, just like this is. Treat it like a string literal with the str command. So here's what they did with the str score. So now it would print the score together. So now let's look at the practice for that. Define main, numbers. There's the three numbers again. Total points, add them together, average. And here's where it prints on it. Your stats, and then a blank line. Total points, and it prints what total points is. The average points prints the average. Let's run it. There it is, your stats. Total points, 271. Average points, 90.33. All right. Can we make that better? Absolutely. Let's see what they've done here. All right, so now they've done the same calculations, total points and average. All they've done is change the print statements. Now they're putting them on the same line. Total points plus put the total points there. Run the program. Oh, we ran into that. It can't do strings and integers on the same line. But if we fix that and tell it to treat it like it's a string, I got to put another parentheses because now I have two open. I got this open and this open, so I need two closing. Tell it to print it and treat it like a string, literal. Now it put it on the same line. Total points is 271. We fixed the error where it could not put those on the same line. Treat it like it's a string, just like it did this. All right, so now it tells us to do the same thing with average. Let's put average on the same line. All right, so let's take out this line. Put plus. I'll put a space just to make it easier to read. String average. Treat it like it's a string value and print the average on the same line. Run program. There it is. Total points 271. Average points 90.33333. So that's how we can print on the same line with string literals. Use the string command to tell it to treat the number just like it would treat anything else. All right, that's the end of the lesson. This just says do the quiz. So let's look at the quiz while we're here. Here it is. Start. You get 2 attempts. So if you don't do well the first time, it'll let you take a second time. What is the purpose of the string function? We just covered that. Read the following code. Which value will this code calculate? X equals current weight, print X minus 20. What does that calculation give us? Good morning, Mr. Granderson. In Python, equations are not evaluated by the standard order of operations. It says it does not follow that. Is that true or false? Not evaluated by the standard order of operations. Number 4, Christina used the following expression to calculate the average ages. However, her output is not correct. What does she need to do to fix that statement? Read the following code written to calculate an average. Here's the code. Which line has the error that will impact the output? One of these lines has an error. Which one is it? And that's it. Now, your questions may be a little different because it has a bank of questions that it'll pull from, but it should be very similar. It may just have a different code for you than that one. But that's it. If you haven't finished any programs from last, and there's very few of you that's left that haven't finished programs from last unit, get that done. If you haven't done the test, I think there's only a couple people that haven't done the test that was due last night. Good job, guys. You guys are getting stuff in good. Get that done. But all you have is 5 questions this week. 5 questions. All right. I will let you guys go enjoy the rest of your Monday. Go do work you can be proud of.